of section 1 in chapter 7. And today we're going to talk about more what polynomials look like. As opposed to evaluating them, we're going to look at their pictures or their graphs. Okay? In order to do that, we're going to talk about the end behavior. The end behavior of a graph is what the graph is doing as x approaches positive and negative infinity. Okay, so basically, if you're looking, whenever you draw a graph, you know how you draw arrows at the end of your graph? You're basically going to tell me what those arrows are doing, is what the end behavior is. Okay, so here is a generalization of functions all the way from a constant function to a degree 5. And as we look through these, I want you to start looking at patterns to see what the end behaviors are doing. Okay, so if we look at the constant function is one that says y equals. Okay, whenever you have a y equals graph, it's always a horizontal line. So we just have the end behavior just going straight out as it goes to infinity. Okay, that one, we kind of ignore that one as we go to our, as we look at the patterns that we have. But when we go to a linear function, we see that we have the slope, so it's a line that's growing. Okay, and if you look at the end behavior, we're looking at essentially what these arrows are doing, which direction they're headed. Okay, so if you were to chop off those little arrows, that would be your end behavior. As x is approaching negative infinity, this one's approaching negative infinity on the y, and this is approaching positive infinity. Okay, here on the quadratic, if you look at what the end behavior is doing here on the quadratic, both end behaviors are going towards positive infinity. We're going in a positive direction. Okay, if we look at cubic, which this is your general cubic function, if we look at our end behaviors here, if you can see that, again we have one going to negative infinity and the other going to positive infinity. If you look at the quartic function, or degree 3, here we have this one going to positive infinity and this one going to positive infinity. So both are going to positive. And then last but not least, we have our quintic, which is degree 5, and one is going to negative infinity and the other is going to positive infinity. So are you seeing some sort of pattern here? I'm hoping you are. 1, 3, and 5 both have one going to negative infinity, the other going to positive infinity. And 2, 4, and kind of 0, not really. But 2 and 4 both have both end behaviors going to positive infinity. Okay, so if something's odd, you're going to have them going opposite directions. Even degree functions are going to be going in the same direction. Alright? Which we can summarize that information in this nifty little chart. Okay, so remember, degree is the biggest exponent, and the leading coefficient is the coefficient in front of the term with the biggest exponent. Okay, so if you have an odd function, think of the cubic function. You should be familiar with that one. If you're not, get familiar with it. You want to be able to picture a cubic function in your brain when we're talking about it. Okay, so whenever you think of odd, generalize it with the cubic function. Okay, so here we have one going to negative infinity, another going to positive infinity. Left to right, we are getting bigger, so we're going from negative to positive, and that is with a positive leading coefficient. When we have a negative leading coefficient, remember that a out in front flips it. Okay, so it reflects it over the x-axis. If that were to happen and we were to flip this graph, then we have our left side going to positive infinity and our right side going to negative infinity. So if you're reading this like a book, odd function with a positive leading coefficient, our end values are getting bigger, going from negative to positive. Negative, because we flipped it over, going from left to right, we're going positive to negative. So notice both of your odds. If I ask for your end behavior, this would be what I'm looking for. It looks like a little ordered pair, but with arrows. So here in the odd, positive, you'd have one arrow down, the other up, and here they would be flip-flopped. Okay, and even, whenever you think of an even degree polynomial, think of the quadratic. We just spent a whole chapter talking about quadratics. We just did a project on it. So think of the quadratics. You should know what it looks like, the u or the n. Okay, so when it's even and positive, the a is positive. Remember that, the a. If A is positive, we get the nice U. Okay, which in that case, both of our end behaviors are going up towards positive infinity. When our A is negative, we flip the graph over and get that N. So both our end behaviors are going down towards negative infinity. Okay? So any even degree polynomial you can generalize by thinking about the quadratic parabola. Okay, and then because all the end behaviors will be the same. Alright? So, let's give it a shot. Determine the end behavior of the following polynomial. Okay, the first one we have f of x equals 5x cubed minus 6x squared minus 3x plus 1. First thing we need to establish is the degree of the polynomial. Is it odd or even? Our biggest exponent is degree 3, which means that we have an odd degree. And it's terrible handwriting, sorry. Okay, and then our leading coefficient right here, our leading coefficient is positive. So I want you to look at the little table that you should have just written down, and what are my end behaviors going to be? If it's an odd degree, you want to think of your cubic function. Okay, so your cubic function with a positive coefficient looks like this. So therefore, our end behaviors are going to be like that. And that would be your answer. Okay? Over here we have g of x equals negative 4x to the fourth minus 7x plus 2. We want to look for the degree of the polynomial, so look for the biggest exponent. Here we have 4, so this is an even degree polynomial. Okay, and our leading coefficient is negative. Okay, so when you think of even degree, we think of the quadratic, so we think of that nice U parabola. If our A is negative, that flips it over, so now we get the N, and if we're looking at an N, that means that our end behavior is looking like that. Okay? Now for these next couple examples, it says for each graph, determine the end behavior, determine whether it is an odd degree or even degree polynomial, and state the number of real zeros. So 3 jobs. So looking at this graph, it says determine the end behavior. Okay, you're going to look at what these arrows are doing, and you're going to translate that into our little ordered pair of arrows. So I have the end behavior of this one going down like that, the end behavior of this one going like that. You're basically going to transpose these arrows into your ordered pair. And that is your end behavior. Okay? If both arrows are going down, if they're in the same direction, does that mean that it is even or odd? If you said even, you are correct. This is an even degree polynomial. And state the number of real zeros. Remember, zeros are where we cross the x-axis. Okay, real zeros are when we are actually crossing it or touching it. Imaginary zeros are when we have no touching of the x-axis. Okay, so here my graph is going through 1, 2, it's going through the x-axis twice, which means that this one is going to have 2 real zeros. Okay? Great. This guy, just out of curiosity, this one, would our leading coefficient have been positive or negative? We're going down, we flipped it, it would have been negative. Okay? Here, we have an end behavior where the left side is going to negative infinity, right side is going to positive infinity. If they're going in opposite directions, that means that we have an odd degree polynomial. Okay. Out of curiosity, if we are going from negative infinity to positive infinity, does this mean that my leading coefficient is positive or negative? Positive, that's right. Positive leading coefficient. That's just a side note because our question asked us that. And then the number of real zeros is the number of times we are crossing the x-axis, which is right there, so we have 1 real 0. Okay? That is the end of end behavior, and that is the end of section 7.1.